Hi, Venetia. Say, per our conversation yesterday, I went ahead and created a little bit of a model representing some of the parts, some of the general parts that I saw in that PDF document that you sent me a few days ago on the O'Reilly Auto Parts sign. And this reflects your desire to put together a document that you can send to the shop floor that would better specify what they actually need to do. So, as you told me yesterday, you're kind of an interface between the design team and the fabrication team, and your desire is to try to get some documents down to the shop floor so they can adequately and maybe without ambiguity be able to build some of the models that you're putting together down there. And two items that you're talking about specifically were a bill of materials and a cut list. So I went ahead and put together a drawing based on a model that reflects all of those items. What I was trying to do here, the motivation here, is try to put together a document that graphically represents what needs to be initially cut and ultimately what needs to be fabricated. Some of the resources I used for this video and for this demonstration is that PDF document that you sent me. I try to include some of the basic elements in here and none of the details, but the basic elements in regard to the extrusion on the side that creates the walls of the sign. Then you have your diagonal uplift and your vertical struts. I went ahead and included those items in the sign in order to demonstrate how they can be incorporated into a drawing. Something else about the model to consider too in regard to this drawing that we put together, in regard to this drawing I was using as a reference, and the model that I put together was something I iterated yesterday, is that once you get the basic template done, and you got to realize too that today's template that I put together is contains only the basics in here. But once you get a good template down here, you should be able to go inside your model, and for a different client, or maybe with a client's desire to maybe make some changes on this, you should be able to take some of the generalized modeling parameters and make changes to it. The width of the sign, the length of the sign, maybe the depth of the extrusion, or maybe using a different part for the extruded, for the walls of the part. That could be done actually relatively quickly, and I'm going to go ahead and demonstrate that. But first of all, before I do that, let me show you around to the drawing. So typically what I like to do is, I put in the basic views, the front view, the right view. The right view over here isn't really labeled. I probably should label that. But we have the front view down here. We have the right view over here, and then we have a section view of the right view. The section view doesn't have the diagonals because the diagonals were put off on the side so we don't have material conflicts. And then if you look at the section view, you can see where some of the pieces, like the vertical pieces, actually make their cut in reference to the whole model. It also shows some of the corners too. So on that section view, I have a couple details over here showing a mitered corner and then a butt corner over here. And then that's reflected in some of the details down here too, so you can see how that looks. So if you want to do that. I think normally you would have mitered corners, but I went ahead and put a butt corner in there just to see how it reflects in our bill of materials and our cut list. Then we have an isometric view, kind of shows you how that comes together in a very generalized way. Now if we go up to the cut list, what I used were weldments up here, and that put together a nice little cut list with a little bit of modifications in here. And you could actually come together with a pretty decent looking cut list. So the parts that I named in our model get reflected over here in our cut list name. The quantity of those parts are in here. The one that actually has a lot of quantity to it are the vertical struts, which I didn't really name correctly here. But and then you go over here to the reference in regard to very simple parts like the extrusion that make up the walls of your sign. I just say the reference is going to be to the right, and it gives you the length, the angle 1 and angle 2. And if it's a mitered cut, then obviously the angle is going to be 45 degrees, and it shows you what the maximum length is going to be on that. And then for the butt corner, it actually shows the angle being 0 here and 0 down here. It should be a 0 over there. It shows you the different lengths. So with that cut list, what happens when you change your model and make modifications to your model, it automatically updates your cut list. So instead of having to go through the calculator with an Excel spreadsheet to try to figure out what those cuts are going to be, you can go to your model and make those changes in the model. It should automatically update in your drawing. So we also have a bill of materials. We don't really have any details in here. We don't have any of the small parts in here, or the nuts and bolts or other items in here. So the bill of materials is here just as kind of a template, maybe a placeholder here. And then when we get those small items in here, then the bill of materials actually fill in. So I made a reference over here for some of the simple parts, like the walls of the sign. But for some of the details that involve more fancy cuts in reference to how the model is actually going to be coming together, I made a reference down below. So with a diagonal uplift and a vertical struts, I call that a cut item 5 and a cut item 6 below, and I included those below. And by the way, the front view also has the balloons for each one of these parts. So 5 and 6 are the diagonal and then the vertical struts. And then 1, 2, 3, and 4 clockwise kind of goes around your model. And something else to consider about this too is that this is just a template. This is how, maybe a starting point regarding putting together a template that might better meet your company's needs. We can go ahead and take this template here and say, well, I like this item here, or I like these items over here, but maybe you don't need these details, maybe you don't need the balloons. We can make modifications to it too if we desire. But this gives us a starting point. So over here for our diagonal uplift and our vertical struts, I am referring to cut item 5 below. And so what I did is I put these items in the box down here. We have our front view, and we have a broken out front view down here, which shows you a little bit more detail. And then on that, we have a section view, which shows you the section of what, the parameters of the piece that we want to cut. I don't know what the size of the pieces there are here, but, those modifications can be made and changed. But again, this is just a concept, you might say. So it gives you the overall length here, so you know that at least 8'7" and maybe 3/4 of an inch size piece here with these 35.54 degree cuts in here will result in this piece that you see here. So again, that angle is going to change when we change our model. So if we were to make that from maybe 6 feet to maybe 7 feet, the angle here is going to change. And over here for our vertical struts, it's a little bit simpler here, but follows the same format. You have the front view at the sheet scale, then you have more of a detailed view here, which at a different scale, which should be a 1:4 scale, or 1:2 scale up here. So this is probably a 1:2 scale down here too. So that didn't get included over here. And then you have your section view over here to show you the details of that. So let's go to our model and take a look at our model. So here's our model, the way it exists right now. And as I mentioned yesterday, the desire with a template like this, it gives you the ability to go into one location like the front sketch. And this piece of sketch geometry here pretty much drives our whole design. And there's a couple things in here that you can actually change to make changes for like maybe a bigger pole. Instead of the diagonals being 12 inches across at the very top of our top of your model, you can make that a little bit longer, maybe 16 inches, and that would reflect in a different length of the diagonal here. But again, that would update into your model, and it would eventually update into your drawing too. So if you need to make changes really quick, you can go back in here and make these changes to this model and get a drawing back down on the floor in a matter of minutes. So let's say right now, instead of 180 inches, you want to make that 200 inches, perhaps, maybe 5 feet. Want to make that 48 inches, 4 feet. And if you update the model over here, you simply go to the update button, the rebuild button, and you can see how everything kind of changes there. So everything's complete. There's no errors over here. If you go to your drawing, it makes an update to the drawing too. Now there's a little bit of fussing with the drawing here, in order to get these details down here to look correct. And some of the details over here are actually incorrect too. So we can take like perhaps that E and move that over detail E and maybe detail F, and move that over here too, right to the corner where it was before. You simply grab the center of that circle and drag that to the corner. And when you do that, it updates your details. So There's a little bit of model modifications over here in regard to making updates to your drawing, but that doesn't really take a whole lot of time. So with D over here, if you right click over here and go to your crop view, you can edit your crop. And right now it's just a spline, so we can go ahead and move that spline over here and then do rebuild. A lot of these updates are actually pretty quick. So regarding these detail views, it looks ominous, looks like it's really dorked up quite a bit, but it's actually fairly easy to correct. If we were to go to this view over here, let's take a look at our angle over here. This is a new angle we're going to be dealing with, 27 and 27.05. So we want to include that into this view. So when we go ahead and update this view, if you go to zoom, pan, and rotate, if you go to the rotate view, you want to type in the correct angle now, 27.05. And then if you go to apply and close, you can see that that front view actually corrects itself. So the other view down here, which is this broken out view, we can go ahead and click in that view, right click, zoom, pan, and rotate. We want to go back to rotate view, and we actually clicked on the wrong one, so we can go ahead and click on the right one over here, which is going to be that view, and do the same thing. I want to rotate that view up. Still picking the same one. Let's go ahead and click on that view and actually move it out of the way, or maybe find a different way. Yeah, it's kind of sticking up over here, so now we can do the same thing over here. So didn't mean to waste your time in that, but that isn't it either. So let's try that one more time. 27.05. We're going to apply that. And yes, it's telling us that one of the dimensions we had in there is not going to come out correct. But we can go ahead and make that correction, which is going to be this dimension. And that's going to be the overall dimension. So we can go ahead and add that dimension in here between that point and this point. So now the total length of that is going to be 8 feet 10 and about maybe a little bit less than 10.5 inches. And then here's our angle. Again, you might want to go through your drawing and make clean that drawing up a little bit. Our section view kind of got moved off to the side, so we need to find out where those section lines went off to, which is actually, it looks like it's down here. So we can move that up here. So we can take that section line, move that up here, and then take the end point of that line and move that up here too. Move that off to the side so we can actually grab that a little bit. So that brings that into view over here, and if you go ahead and rebuild, that brings that section back in. And we can delete these dimensions, which actually refer to the section below. And then along with the drawing cleanup, you want to make sure you get your section views in there. But you can see, just to demonstrate this and how this works, that you can very quickly be able to generate a whole new drawing for a whole new model with different dimensions on that, and create these shop drawings for your shop relatively quickly. So in summary, what we have here is a drawing format based on a model. The model is based on a simple sketch, the front sketch. And with that front sketch, you can make generalized modeling changes to your model. And from those modeling changes, you can go ahead and rebuild your model and get that reflected back in your drawing, so you can go ahead and generate shop drawings down there for your shop guys. And then with your cut list, the cut list gets automatically updated. And of course, with the details I showed you below, you can include that into this drawing, which would include a lot of the cut details. Then your bill of materials, once we get an assembly together, will include all the nuts and bolts and some of the smaller parts that would go with your design. It would include that in your bill of materials there too. So bottom line, with a model setup like this in SolidWorks, you can make very quick generalized modeling changes which reflect back into the model and eventually for reflecting your drawing, automating your design quite a bit and being able to increase your productivity. So thanks for joining me. We will talk to you soon.